All right, so let's see what you thought. So looking at part C, let's start by just talking about the middle charge, charge Q2. Okay, so if I took out charge Q1, remember we drew the FBD originally and there were two forces pulling it to the left. Without Q1, the new FBD only has one force pulling it to the left. Okay, so what we can say is that if we start with the magnitude actually gets a little bit smaller. The number drops because now there's only one force pulling it to the left as opposed to two. But we can see that the direction is still the same. So the direction of the net force is still to the left. So in this case, the answer would be the magnitude decreases, it gets smaller, but the direction stays the same. All right. Now, for Q3, it's a little bit different. We know that the FBD for Q3 originally had two forces, but one was going to the right, one was going to the left, which means they tried to cancel each other out. If we take out charge 1, the new FBD only has one force acting on Q3, all right, the force from the second charge, which means now the only force acting on it is pushing it to the right. So direction actually changes because we saw up here the net force is to the left. Now the net force is to the right. Also, because there's no left force trying to cancel it out, the net force actually increases. So the amount gets bigger. So in this case for Q3, if I take away that first charge, not only is the net force now going the opposite way, but it's actually applying more force than it was before. Okay, and take a second. I'm going to leave it just like this. Pause the video if you want. Read over my answers. Okay, because I know I talked kind of fast. Just kind of ponder it a little bit. All right. Now, with that being said, let's look at the last piece of this before we get to the end of this first video. So, the first question, or at least the last question on this page, is just a very simple drawing. Okay, so this individual, this student, has two charged particles near each other. One has a charge of positive Q, one has a positive 4Q charge. And what they've done is they put them near each other and they've drawn two force vectors. So basically what they've done is they've drawn two FBDs. One for the particle on the left, one for the particle on the right. There is something wrong with this diagram. Okay? I want you to explain what it is, and I want you to correct the diagram so that it looks correct. So, I want you to pause the video here, try to figure out what's wrong with it. And then once you think you got it, unpause the video, let's see what you said. Let's see what you answered. All right, so if you had a chance to write down your answer, the issue with this particular drawing is that it misunderstands how forces work in this sort of situation. Okay, so in this case, these two charged particles are going to repel each other because they're both positively charged, which means they're both going to exert an electric force on the other one. The issue is that using Coulomb's law, it doesn't matter which charge you're looking at here, they exert the same amount of electric force on the other one. All right, so whatever the charge Q, the particle A is pushing on particle B with, particle B is doing the same thing to particle A. Okay, it's similar to the idea of Newton's third law, just the idea of the action-reaction sort of idea. So, with that being said, that means that this drawing is wrong because the two force vectors are different lengths. And to make it correct, we need to draw them so that the two force vectors are the same length. Okay? Now, the direction they're pointing is exactly right because they are the same charge, so they want to repel each other, or the same sign charge, I should say. It just needs to be the same length as well. All right? So, with that being said, this is the end of the first video. So this is the end of our discussion of the first side of the notes. All right. The next video is going to talk about the second side of the notes as well. So head to Canvas, click on that second video, and we'll keep working through this.